So in the last lecture, you learned about abstract base classes. As another example, here I have defined an abstract base class called UI control. This class has an abstract method called draw, and as you can see, this method has no implementation. So this class only defines the contract or the interface that all its derivatives should follow. Okay? Now, here we have two classes that derive from UI control. One is textbox and the other is dropdown list. Both these classes implement the draw method. Here we simply print textbox, and in the dropdown list class, we print dropdown list. So nothing new so far. Now, here we also have a function called draw that takes a UI control object and calls the draw method on it. So with this, I can create a dropdown list object, dropdown list, and pass it to this draw function like this. This should be perfectly fine because the dropdown list is an instance of the UI control class. To verify this, let's call isInstance function and pass this DDL object as well as the UI control class. And then print the result on the terminal. For now, I'm going to comment out this line. So save the changes and run the program. We get true. So a dropdown list object is an instance of UI control. And that means wherever we expect a UI control object, we can pass any of its derivatives, like a text box or a dropdown list, right? So let's delete this line and call the draw function with this DDL object. What do we see? We see a dropdown list. Now, what if we pass a text box to this function? Let's take a look. So I'm going to create a text box like this, and then pass it to this draw function. Run the program. This time we get text box. Now you might ask, what is the point of this? Well, let's take this to the next level and make it more interesting. I want to change this draw function. So instead of getting a control object, I wanted to get a list or a tuple of controls. So let's rename this to controls. And here we'll use a for loop to iterate over this controls object. So for control, in controls, we call the draw method on each control object. Now, we're going to pass a list of two objects, a dropdown list, and a text box. Let's run the program and see what happens. As you probably expect, we get two messages, dropdown list and text box. So using this approach, we can render the user interface of an application. Imagine we have a form with a bunch of text boxes, dropdown lists, radio buttons, and so on. We could have a list of all these objects and pass that list to a function like draw, and that function would take care of rendering the entire form. What is interesting here is that our draw function doesn't know what kind of control it's working with. This is determined at runtime. It simply iterates over the list of controls and calls the draw method of each control object. This is what we call polymorphism. Poly means many, morph means form. So polymorphism means many forms. In this example, our draw method is taking many different forms, and this is determined at runtime. We could be calling the draw method on a text box, or a dropdown list, or a radio button, and so on. So this is the classic example of polymorphism.